If you're going through the series in order, you've now seen MGCP, Media Gateway Control Protocol, and what it's all about. It's time to move. We take that knowledge, put it into a nice little bucket, and kind of set it aside and say, okay, that bucket's full, sloshing over. That's our MGCP bucket. Now let's move over to a brand new empty bucket for H323, a totally different voice signaling protocol. So the same kind of concept I'm going to take you through with H323 as I did with MGCP. I'm going to walk through the definition. What is H323 and why would you use it? I mean, what makes H323 better or worse than MGCP? Then I'm going to look at a call flow, and I want to do this with you in depth so that you can see how an H323 call is set up, and when you're troubleshooting, that'll play into a big part of, oh, well, those messages didn't go through, or that didn't negotiate right. So I'm going to show you that. I'm planning on doing it on a live call manager system with a router using some debugs. It'll be cool. And then finally, we'll look at the H323 defaults. It is the default protocol in a Cisco router, so what's it going to run like by default? How does the Cisco router handle it? Well, I'd like to start H323 out just like I did MGCP, by defining it. What's the point of H323? Well, just like MGCP, H323 is designed as a voice signaling protocol. Its goal is to set up and handle voice, video, and data calls between two devices. Now, I expanded a little bit from MGCP. MGCP was just to set up calls, to make them happen, to control gateways and that kind of thing. But H323, its goal is to be a protocol suite. That's because, as I think I mentioned early on in the series, H323 was designed for the old ISDN networks. And when ISDN came out, people were like, oh, ISDN. This thing rules. This will be the be-all, end-all of all data connection. Because, I mean, back then, we're talking like 2400 baud, 9600 baud modems, and people were like, ISDN is so much speed. It's kind of like Bill Gates with his 640K of RAM. You'll never need more than 640 kilobytes of RAM. And nowadays, ISDN, just like 640K of RAM, is like, it's old news. So H323 back then was designed as a whole protocol suite. Like, it does it all. Voice, video, data, all over ISDN connections. Now, ISDN kind of went along the way with the data world anyway, and H323 stayed around, but they tuned it to run over TCP/IP. And these are the major components inside of it. And before I even get to that, I also want to mention H323 is a peer-to-peer voice signaling protocol. Remember what MGCP was? Client-server. Meaning the gateway had no intelligence at all. It was like a mainframe and got all of it from the call agent. Well, H323 with the peer-to-peer model, I mean, think of that in our workstation world. Remember our workstations when we set up peer-to-peer networking? Each one of these computers has its own database of users, and as the network gets bigger, it just becomes unmanageable because everybody needs their own database of users and passwords and all that. And that's why we moved to a server model, to where that's the central database and everybody trusts the server and that kind of thing. And that's what MGCP does. But H323 uses the peer-to-peer model. Now we can ease that by using a gatekeeper. More on that later, but that's its design. So inside of the H323 protocol suite is a whole bunch of other protocols. Now I'm not even showing you an eighth, maybe a quarter of the protocols that are in H323, because H323 includes RTP, RTCP, it includes all of the audio and video codecs that we use when we're setting up our audio and video calls. H323 is the whole deal. It's everything all in one protocol. And that's one of its disadvantages, is because it was designed as a protocol suite. It's not really scalable, upgradable, like let's switch these parts in and out. To switch parts in and out and add new things would be kind of like, to change things in TCP/IP and be like, we don't really need that TCP thing anymore. Let's swap it out. I mean, that's like, okay, let's change the world. Well, these protocols in H323 are the main ones that are useful for setting up the calls. And if you're studying and you're committing some to memory, I'd remember these three. H225 is the piece of H323 that handles the call setup and teardown and Q931 operations. It was actually designed using Q931 standards. So in a lot of documentation, you'll see, oh yeah, we've got the H.223 gateway, and it's doing some H.225/Q931 signaling to the PSTN. Meaning, again, Q931, this is from MGCP Nuggets, is the layer 3 of the ISDN model. So H.323 understands ISDN signaling. Now, keep in mind, I didn't say understands QSIG. That's something specific to MGCP backhaul, where you offload that QSIG processing to the call manager. But H.225 is really the same thing as Q931. So that's the call setup and teardown. You've got a call coming in. First thing that's going to take action is H.225 in the H.323 protocol suite saying, let's set this call up, and when it's tearing it down, disconnecting, that's the last thing to take effect. Now, there's also H.225 RAS, which sounds like the same thing as H.225, but it's not. This stands for Registration and Admission. It's not Remote Access Server. Remember RAS, Windows 2000 or Windows 2003 RAS server? That's not what this RAS is. It's Registration and Admission. It deals with the gatekeeper, and S is status, by the way. So when you have a gatekeeper involved and a gateway linking up to the gatekeeper, remember gatekeeper is the centralized source of everything for the gateways, they will speak and communicate with that gatekeeper using H.225 RAS. Now H.245, that's the last, I'll say, important protocol of them all. This handles the feature negotiation, and I'll talk about this when we look at the call flow. But after the call is initially set up, like let's say we've got a call manager server here, CCM, and we're starting a call between the call manager server and the gateway. H.225 starts it and does the setup. Right after H.225 is H.245 saying, well, let's see what features we've got. What codec are you using? And negotiates the codec between the two. And I would say that's the major feature that you're looking for, is the codec. Coder-decoder negotiation, like G711, G729. What kind of language are you speaking for the audio? Now the other ones here, they're significant, but not as significant when we're dealing with voice. For instance, H.261 and 263 is used for video conferencing. H.450 is used for supplementary services, like when you're on a call and you hit the hold button or transfer, those kind of supplementary services. That's all done using H.450 signaling. And then down here we have T120. That's used for data sharing. When you connect a call using H.323, your applications have the option of doing data sharing. If you remember the old Microsoft Net Meeting, that was a killer application back in the day. Not many people used it though. It would allow you to do a voice and video conference, and you have like shared whiteboard applications. You could share your desktop with another user. That was all done using T.120, which is just a standard H.323 use, or a protocol it used for application sharing. So now let's dig into the reasons why we would use H.323. I mean, I mentioned it's an old protocol. Why would you use an old protocol? Well, there's lots of reasons. First off, and I'll actually hit this guy first on number 3. It says widely supported interoperable, meaning this protocol is like TCP/IP. It's been around for a long time. So just about every single vendor is going to support it. So you've got your Cisco equipment trying to tie to some other heathen brand equipment, and you need some kind of protocol that's going to be able to speak between the two. Chances are everybody's going to be able to support H.323. It's just one of those things. It's kind of like, TCP/IP. Everybody just runs it. So you've got that wide support, and I should mention that this is the default protocol on Cisco routers. When you configure a dial peer and you start setting things up, by default the Cisco router's running H.323. You have to set it up for MGCP with the MGCP commands, turning it on and all that kind of stuff. Second reason, I'll work my way down here, you want fractional PRI support. MGCP does not support fractional PRIs. It only supports the whole shebang. You've got all 24 channels in use, one signaling channel, and so on. H.323 is the one that is able to support fractional PRIs, like a partial PRI line. Here's a big one. You want caller ID support on FXO or T1 CAS. MGCP does not support caller ID on FXO ports or T1 CAS. So again, if we go back to you're using the call manager to control that gateway, if you've got lines to the PSTN and you know that's an FXO, and you want caller ID information to be relayed into the network, you got to use H323. And same thing's true of T1 CAS. So you can imagine most people use T1 CAS with H323 because caller ID is a pretty big deal. Down here, let me. I'm just jumping all around. I'm just gonna put little marks next to these as I talk about them, so I can remember where I'm at. I want to jump down to this guy, call preservation. PRI call preservation means that since H323 is a peer-to-peer protocol, if the call agent dies midstream, you've got 12 calls active on this is a T1 line, a PRI line to the PSTN. If the call manager dies during that, that's okay because the protocol is running all within that router. It's peer-to-peer. So all of the calls that are active still are maintained while that call manager reboots and you get it back online. The same is true. I mean, if you're running a T1 CAS line with MGCP, it can do call preservation as well, since T1 CAS is all layer 2. It's all happening over here at the router. It doesn't need the call manager for that. But if you're using, and this is one to know, if you're using MGCP backhaul, calls are not preserved if the call manager fails. And if you think about it, that just makes sense, right? I mean, the call manager is handling the layer 3 processing of the PRI line with MGCP backhaul, what we talked about in the previous nugget. So if the call manager dies midstream, all 12 of your calls go with it. So there is no call preservation in MGCP PRI lines. So now let me jump to number 4, keeping you on your toes. Mini call routing and manipulation options. I'm going to show you as we get deeper into H323, especially in the later nuggets, where you have the ability to change dial digits, caller ID information, manipulate it using all kinds of system, regular expressions. I mean, it's very flexible. So you have many options with that. I already mentioned it's a protocol suite, so you've got the voice, video, and data. It supports NFAS. That's a new one. Non-facility associated signaling. What that means is you might have a scenario where your organization is big enough to have, we'll say, 3 T1 lines to the PSTN. And you want to use PRI signaling, but man, taking a channel out of each one of those PRI lines, you start adding up. That's 3 total channels. NFAS allows you to use a single signaling channel for multiple PRI lines. So I can go in and control all 3 of those T1 lines using a single signaling channel. Just carve one D channel out of one of those T1s, and NFAS allows you to send all the signaling for all 3 of those over that one line. The result, you have more usable channels. So last but not least, H323 gatekeeper support. This allows you to use, just like it says, an H323 gatekeeper on your network. So that gives you a centralized, remember the goal of gatekeepers is to give you a centralized point of call admission control, of dial plans. It's the centralization of everything. Because H323 is designed as a peer-to-peer protocol. Everybody's supposed to have their own intelligence. Well, when a gatekeeper comes into the picture, it peers up with these guys. Keep in mind, the gatekeeper doesn't control these gateways then, if these are H323. It just becomes a peer to them. To where now, these gateways down here say, well, I don't know where that phone number is. Let me ask the gatekeeper. Hey, gatekeeper, do you know? It's more of a questioning rather than the gatekeeper coming down forcefully and being like, this is your dial plan. You must do this. So that allows you to tie in with H323 gatekeepers, which is a big part of centralizing your whole voice over IP network. All right, now let's talk about the H323 call flow, meaning what's it look like to use H323 to run a gateway and manage calls going between the gateway and router and so on. Now, H323 is a call signaling protocol, and we mentioned that earlier. So our gateways are going to run it, and let's say we've got H323 managing, we'll say this is an FXO port to the PSTN. We want that caller ID support, so we use H323. And by default, that's what the router uses, so we can even tie it to the call manager. So let me walk through these steps, and you can see I've got my little star up here, demonstrated using Call Manager 6.1. I'm going to actually walk you through the setup of a gateway and call manager relationship, and then use a debug command to watch this call flow. So the first step that's going to happen when we use H323 is the call. Let's say, sorry, let me give you a scenario here. Let's say this phone, let's say receives a call from the PSTN. So we got the call going this way. Call comes from the PSTN through the gateway to the phone. Well, what's going to happen is it's going to come into the call manager, or the router here, and the router is going to say, okay, I just received a call on my FXO port. What do I do with it? Well, I'm going to, and this is part of the configuration, I'm going to send that into the call manager. So using H323, it will send an H.225 message. That's our call setup message on TCP port 1720 over to the call manager, and the call manager receives it and goes, oh, I've got a call setup message. What number are you looking for? And it says, well, I'm looking for extension 2000. Now that would have had to been configured on the gateway. I would have to type in, when a call comes in on the FXO port, send it to extension 2000. And actually, in the next nugget, when I talk about all the configuration scenario, I'll show you how to do that. But so it receives the call. It says, I'm looking for extension 2000. The call manager then sends H.245 messages saying, okay, well, let's negotiate the features, what kind of codec you're looking for, and all that kind of stuff. So H.245 comes second and performs that feature negotiation. Now, once all of the feature negotiation and setup process takes place, Call Manager then rings this phone, not using H323. These phones can't run H323. These phones, by default, run Skinny. So or I guess the official definition, SCCP, Skinny Client Control Protocol. So the call manager almost relays or acts as a proxy and says, hey phone, ring, I've got a call for you. Phone rings, and now the RTP stream, you can see step 3, moves from the PSTN through the gateway to the phone. It doesn't go through the call manager. So the phone's talking, hey, how you doing, Bob? Yeah, I saw him yesterday. Yeah, he was swiping some information. Yeah, well, blah, blah, blah. So the conversation's going on. I just make up conversations in my head. And so they're done with the call. He's like, okay, thanks, Bob. Click, hangs up the line. Skinny message saying, we're done. H240 or H225 message comes back to the gateway saying, okay, call teardown, disconnect, we're done. And that tears the call down. And now, before I go any further, I also want to mention my note in red down there that says H323 Fast Start combines H225 and 245 negotiations into a single message. Meaning, when the call setup message comes over here, it also includes H245 feature negotiations saying, hey, let's use this codec, let's communicate in this way. So it minimizes the number of messages that are sent. It's just a more efficient way, and that's what a lot of things use by default nowadays. And you can see that's default on Cisco routers. So let me show you the setup of this on. I'm going to do a gateway and a Cisco call manager, and then do a debug. This is the same router I used to demonstrate MGCP. So what I'm going to do is I've still got that FXS port connected to my garage sale phone right here, and I've modified this router. It's the 2801 router. I've modified it and removed all of the MGCP configuration. So we're again back to scratch. So I'm going to use H323 to define an extension for that FXS port, and then define the call pattern that will get it to the call manager. So watch this. Where's my voice router? There we go. So I'm sitting on the voice router. Do a show voice port summary. Again, I've got the analog phone connected to this port, 0/0/0. I just lifted the receiver. You can see it just went off hook right there. So that verifies. I've got the phone plugged into there. So what I'm going to do is I'm going to go in and define a dial peer. Now this is straight out of the C-Voice series. Configuring an H323 dial peer defines dial plan information. It's not centralized anymore using MGCP. So I'm going to do dial peer voice, give it a tag, and most people make the tag match the phone extension you're using. Doesn't have to, but most people do. We'll say the phone is going to be extension 1800. Oops. And it's going to be a POTS phone. Because it's connected to an analog line, you usually will either use POTS or voice over IP. Voice over frame relay, hardly ever used, and multimedia over IP, that's when you get into video telephony. So voice 1800, so I'm going to say the destination pattern is how we define our extension, 1800. And the port that I'm going to send it out is 0/0/0. That's it. That's how we define call extensions in H323. And again, if this is a little vague for you, the next nugget will go fully into all the configuration examples. I'm just setting this up to show you a debug. The second thing I need to do, let me just get back to the diagram here. I've now defined this guy as extension 1800, FXS port 000. I now need to say when somebody dials, and let me verify here. Where is my call manager? There we go. I'm bringing up my call manager right now. The call manager, all of my extensions on there begin with 2. They're extension 2000. So I've got the phone sitting right next to me. The one I showed you in MGCP, this 7970 phone, is extension 2000, and I've got 2002, 2003. They're all auto-registered. That's where that auto comes from. So what I'm going to do is I'm going to go to the gateway and create a voice over IP dial peer, and I'll just say dial peer voice, let's do 20, and we're going to say this is going to be voice over IP because it's going over the IP network. It's not a directly plugged in phone extension. The destination pattern is going to be 2 ... and you can see whenever you type destination pattern, it just says word. You know, I love context sensitive help that's like word, like just type in word up. So I'm going to type in 2 ... which says any 4-digit extension beginning with the number 2. Dots are little wildcards. Again, tune into the next nugget for more on that. And I'm going to say that the destination I'm going to send it to for voice over IP dial peers, I say session target, and again, it's our lovely word, IPv4 : actually, I want to show you something. I want to see the ugliest context sensitive help you've ever seen? Look at this. Sweet. It says must be of the form. It's, you know, I don't know why they couldn't have made that into a question mark right there, but they didn't. So I'll say the session target, and I'm using this form right here. It's an IPv4 : address 172.30.100.104, which is the call manager. Now, man, I didn't plan on getting into this much config in the call flow video. So what I'm going to do, let me do this. Here's what I'm going to do. I'm going to go into the call manager and I'm going to set up the gateway. And I'm just going to pause the video because it's going to take me a second, and it's part of the configuration nugget. I'm going to set up the call manager to recognize this H323 gateway, because you can't just have calls coming from this mystery gateway that the call manager doesn't know about into the call manager. You have to configure the call manager for it. So I'm going to do that configuration and then bring it back. All right, I'm done. Don't you love the magic of video? It was instantaneous. I set up the gateway and the call manager. Again, I'm doing that just because I do all of this in the next nugget in the configuration, so I don't want to, I can't spoil it all before then. So what I've done is I've got both those things set up now. And I'm now going to do a terminal monitor so we can see some debugs. Oh, actually, it's on already because I see this message. And I'm going to do a debug H225. You can see it's got specific ones for H225 messages and H245 messages. And I'll do debug H225 events. Show me, what's going on there. Whenever an event happened, which H225, and let's do the same thing for H245 to watch the events occur. Now, what I'm going to do is I'm going to pick up this analog handset next to me and dial extension 2000. 2000. Now the phone right next to me just started ringing, the IP phone, and you can see all this gibberish going across the screen of stuff going on. And actually, I'll just keep that thing ringing in the meanwhile. You can see that as I placed that call, it immediately saw a connect message come through. Now, this, since I'm debugging H225 and H245, is the H225 setup message. Now, it comes through and says, okay, we've got the connect in progress. It's taking place right now. Meanwhile, you can see, let's see, where is it? We've got H245 that is encoded as fast start. Remember, I said that was default. Fast start is default, so that as it's negotiating the connect and the H225 setup, it's also negotiating the fast start, meaning what codec are we going to use and all that kind of stuff. So fast start takes place, and then we have this is the hex representation of the setup packet. All this junk, and that's encoded because H220 or H223 is not a clear text protocol. And when we do SIP, you're going to be like, oh, that's beautiful, because SIP is so easy to understand. There's no encoded mishmash with SIP. So it shows, these are all the setup messages being sent back and forth. It's negotiated the port numbers that are going between the two, and the phone's ringing right now. So let me lift the handset of my IP phone. I just did. You notice right there, as soon as I lifted the handset, we've got the channel created, H245 takes over. That's where it's encoding and decoding all the messages. These are all the feature requests and so on. Now here's a tip. There's a lot of times where the codec is not exchanged until the handset is answered. So when this guy is ringing this phone, remember it's going through the call manager, so it's not a direct arrow like this. The phone is ringing, and as soon as the handset lifts up, it'll negotiate the codec. Now there's some troubleshooting that you might run into when somebody lifts the handset of the phone. All of a sudden you hear a fast busy signal, and you're like, well, that makes no sense. Why do you get a fast busy signal as soon as somebody answers? Well, the reason why is a lot of times the setup message goes through just fine, like, hey, let's ring, but all of a sudden when they answer, the codec negotiation, which you can see some of which happening right here, it's encoding and decoding the messages going back and forth. When the codec negotiation takes place, it fails and says, oh, I'm sorry, you're using G.711 and I'm using G.729. And that's, by the way, the default codec of voice over IP dial peers is G729. So we can't talk, and that's when we get the fast busy signal right after the answer. So right now I've got the call in session, and I'll say, okay, I'm done with you. Click. I hang up the phone here. Click. Hang up the phone on this side. You can see now we've got, notice all of a sudden it pops up, H225 parsing some data, a Q931 release complete. Remember I said H225 was based off of, it was built on the same standards as Q931, the ISDN signaling protocol. So don't be surprised when you see these things used synonymously. It's the same kind of messages. That's what lets H323 work so well with the PSTN and using, caller ID and all that kind of stuff. It uses the same kind of signaling, Q.931, which is well understood. So that's a view of what the call flow looks like in action between a gateway and a call manager using H323. All right, last thing I want to talk about here is the H323 defaults. Like, it's running on a router by default, so what are the features that are supported by default? Well, with H323, you use dial peers to define your call plan information, and you can create, as you saw when I just did the call flow, either voice over IP or POTS dial peers. These guys use to connect to IP destinations. These guys use to connect to legacy voice destinations like ports such as FXS, FXO, T1, PSTN, PBX systems. So if you're creating voice over IP dial peers, by default, it uses the G.729 codec. And you'll actually see it listed, let me bring up the router, as G.729 R8. Let me show you. I'll do dial peer voice 20, and we'll say codec, question mark. And you see that we've got G729R8 and G729BR8. R8 just means the rate that it's sending at, which is 8,000 bits per second. That's the compressed codec. You also have BR8, which you can turn on, and that contains VAD, voice activity detection, which, boop, you can see right here, by default, VAD is enabled. What VAD does is cut out the sound of silence from your voice calls. Meaning, when you stop talking, it stops sending bandwidth. It's an extra bandwidth saving measure. Now, let's see, how can I say this and be politically correct? VAD seems very cool. Very cool when you look at it on paper, because you find out that there's somewhere between 30 to 40% of every voice call is actually silence. It seems bizarre to think about it that way, but I mean, listen to me talk. Right there. Silence. Right there. Silence. And what voice activity detection can do is while people are on the phone and they're thinking, they're taking a breath, all that kind of stuff, it cuts out the audio and saves you bandwidth. And it's like, wow, so you're saying I get 30 to 40% of my bandwidth back? Yes. That's absolutely what I'm saying. So that's what I'm saying. It sounds too good to be true, and it is. VAD seems cool at first, but most people will disable it pretty quickly. Because if you get too many voice calls going, meaning 3 or 4 of them, the router gets overwhelmed and it can't keep up with the okay, turn it on, okay, turn it on, turn it off, turn it off, because it's really turning on, turning off these voice flows all at the same time. And what you end up with is you hear these clips. When people talk, you hear their when they first start talking after a moment of silence, it'll clip the beginning of their conversation. It just sounds like the call's cutting in and out. And so most people are like, lame, let's disable it. So you'll see it with the command no VAD, people turn it off. DTMF relay disabled, so all of the digits sent in band. Preference 0. We haven't talked about preference yet, but I can set up multiple dial peers going to the same destination. Like let's say I've got a T1 line to the PSTN, and I've got an FXO port connected as a backup if the T1 line gets overwhelmed, like it's out of channels or it goes down, FXO port can take over. Well, you can do that by creating duplicate dial pairs saying to get to the PSTN go this way and setting them with different preferences. Lower preferences are preferred. It makes no sense, but that's how they do it. You know, the lower you are, the more preferred you are. So by default, when you create a dial pair, it's preference 0. You know, the not so preferred ones would be preference 1, 2, and it goes all the way up to 9. Audio and signaling, man, I'm going to talk about that a little bit more later. This is quality of service markings. By default, voice over IP dial pairs will flag the audio as DSCP expedited forwarding, meaning it's high quality, you want the network to treat it well. The signaling is tagged as assured forwarding 31, which is IP precedence 3, low drop preference. And wow, we'll talk about that later. There's a lot to that discussion. Hunt stop disabled, which means it will keep hunting through dial pairs if the first one can't get it there. That goes also with this preference. You know, if the first one can't get you there, keep hunting. Hunt stop means stop hunting. So it's disabled, it'll keep hunting. RSVP is best effort, and this is another type of quality of service that says I want to reserve bandwidth on the WAN link. It's not going to do it by default. It's just going to say, hey, I want some best effort traffic. Fax relay is disabled. More on that later. I'm just dumping the defaults, trying to give you the 10,000 foot view. You know, I'm not going to dive fully into these because this is a lot of the rest of the series. Playout delay is 40 milliseconds. What that means is as packets are coming in, you know, you have all these voice packets coming into the router, there may be little gaps in between them. Now, if you've gone through the quality of service series, what are those gaps called? Little differing gaps between those packets. Jitter. That's the name for it. They're called jitter, meaning delay variation. So when you're on the phone, you can't have gaps between your audio. Otherwise, that's clips. That's like, oh, sorry, you were cutting out. You just sound funny. You know. So what happens is inside of this router, there's something called a de-jitter buffer, meaning a little buffer inside of here that collects the packets and says, okay, let's get them all in order here and get them all nice and squished together. And that de-jitter buffer is 40 milliseconds. So if you've got, you know, a little gap of 10 milliseconds there and maybe another little 20 millisecond gap over there, it'll give these guys a little 40 milliseconds delay buffer that allows everybody to catch up so it can give a nice smooth play out to this phone. So what that means is you've got jitter more than 40 milliseconds, like you got a 45 millisecond guy right there. It's going to say, sorry, that packet gets dropped. It doesn't make it into the de-jitter buffer in time. So those are the defaults of the voice over IP world. Now let me just quickly hit the POTS. POTS direct inward dial is disabled, meaning the call does not relay directly from the PSTN to an internal extension. You have to configure that. We'll actually do that in the next nugget and enable direct inward dial. Preference is also 0, same thing as here. So multiple dial pairs, they'll all be created with same preference by default. You need to type in different preferences if you want them. A digit strip is enabled. This is an interesting one. If you've got a dial pair saying, you know, connected to the PSTN right here, and it says anything beginning with 9, you know, when somebody dials for an outside line, they type 9, they get a second dial tone, and then, you know, we'll say, you know, some series of digits goes to the PSTN. Digit strip says I will strip any explicitly defined number. Meaning, when you go into the dial pair, just like I did before, and I type in destination pattern 9 ... you know, goes out to the PSTN, the 9 is an explicitly defined number, so it strips it before it sends it out. Now, sometimes that's a great feature because you're like, oh, that's great, you know, because the PSTN doesn't need that 9. So the router's like, let me just take that off for you. Thanks, router. But there may also be times where maybe you have a destination pattern of 9, you know, destination pattern 9 1 ... or 9 0 1 1. And I'm talking about the North American numbering plan here. This is for long distance. This is for international, you know, ... and all your dots here to define your patterns. Well, by default, the router will strip your international dialing code and your long distance code, the 1. And that's not good. So you might have to tweak the digit stripping. Again, more on that when we get into the H323 configuration. By default, it will strip any explicitly defined digit. The POTS dial pairs automatically register with the gatekeeper. What that means is that when you configure a router, and this is a cool feature, when you configure a router to link up with the gatekeeper, you might have, a PSTN connection over here, a couple FXS ports right here, maybe an FXS port over here. By default, the routers will all register their extensions, whatever POTS extension, notice I'm talking about POTS, whatever POTS extensions they have will automatically register with the gatekeeper, so the gatekeeper will build a dynamic database of every POTS extension that they have in the network. Pretty sweet, huh? So that allows you to let the gatekeeper just know about everything on these routers. And when this guy's like, hey, somebody's calling extension 7000. Do you know where that is, gatekeeper? Gatekeeper's gonna be like, oh yeah, sure thing. Router 2 over here registered extension 7000 with me dynamically by default when you created that POTS dial pair. So that's on by default, which is great most of the time, because think about it this way: you might have, and this is a scary situation. You might have, let's say, router 1 over here is in Texas, and router 3 is in Florida. Both of them have PSTN connection, and you've configured both PSTN connections for 911 dialing. So when somebody dials 911 in North America for an emergency call, it goes out that line. Well, both of these routers are going to register that 911 extension with the gatekeeper. Oops. And if it gets two equal cost extensions, it's going to be like, oh, well, I'll load balance. So, somebody on router 2 dials 911, it's going to go to the gatekeeper and say, hey, you know where 911 is? It's going to be like, oh, yeah, go to Texas, and it goes out the Texas line. And then next 911 call, there's an emergency there. It load balances and goes out the Florida line. So you have just this mess if you do this incorrectly. So you got to keep that in mind. And just like up here, hunt stop is disabled, so that just means the router's going to hunt through as many dial pairs as it can to find a path to whatever POTS destination you've defined. So a lot of information. That's like a fire hose of information on H323, the core architecture of the protocol, what the protocol looks like, how the Cisco router runs it. We looked at the definition of H323. It's a peer-to-peer voice signaling protocol. It's a whole protocol suite. We looked at why you would use it, a whole laundry list of reasons, like caller ID on FXO ports. You can't get it with MGCP or T1 CAS ports. Call preservation on a PRI line and fractional PRI supports. A lot of good things to remember of why you would use H323. We then looked at a call flow with a live debug and watched it happen. And then we looked at the defaults of H323 on a Cisco router. A lot of defaults that you'll want to know when you're configuring it, because if you are setting things up, things will just start happening. You're going to go, why is that? Got to remember those defaults, because there's a lot of things that affect how your voice network works. I hope this has been informative for you, and I'd like to thank you for viewing.